Welcome friends, in this one take a look at answering this question. It's a 2018 AP Calculus BC for response questions, section 2 part B, and this is question number 3. So it says, the graph of the continuous function g and the derivative of the function f is shown above. The function g is piecewise linear for -5 through +3, and it's equal to g of x, which is equal then to 2 times x minus 4 to the second for x between 3 and 6 inclusive. The first part says if f of 1 equals 3, what is the value of f of -5? You just have to do this through integration. So, in other words, take a look. F of -5 would be equal to f of 1 plus the integral that you would get. And then you would integrate here from 1 up to -5 and g of x, or meaning f prime of x, in other words. However, f of 1 plus, and then you can just flip the sign between them and change the upper and lower limits of integration. Just make the sign here negative. That's okay, that's allowed. And then you can make this so it looks more natural. -5 now as the lower limit of integration, 1 as the upper one. And then here's still g of x dx this way. This can be done pretty easily. You see, we're told f of 1 is already 3, right? Then you're going to subtract, and then you have to evaluate this integral between -5 and 1. So within parentheses, look at the picture here. This area right here, okay? This one right here. That's -9 because it's 3 down and then 3 across. So when you multiply, you get -9. Then from there, what you have to do next is compute this bit of area right here. Let me shade on there. See this bit of area? This little triangular looking shape right here. So to do that one, again, it's still negative because it's between the x-axis and that graph there below the x-axis. So here it's going to be minus, therefore, and you're going to say 1/2. Now the base of this triangle here is 1, okay? And then the height of it is 3. So -1/2 times 1 times 3. Then you're going to continue. The next piece that you have to focus on is this piece right here, see? This is again a triangle. You can kind of shade it in this way. And you see that one would be positive. So when you do that, you're going to have to do the following here. Plus 1/2 the base. The base is still 1 if you look at the picture carefully. From here, there's just simplification work. Let's work this out. It's going to be here the following. Equals, and you're going to do the following. 3. And then it's going to be plus 9 once you distribute the negative. And then from there, it's going to be 1/2 right here times the 1 times the 3. But then you distribute the negative, so it's going to be plus basically 3/2. And lastly, it's going to be 1 times 2 times 2. That gives you 1 because the 2's cancel. And then distribute the negative into it, so it's going to be -1. When you work all of this out, here is going to give you 11 plus 3 over 2. And then 2 times 11 plus 3 is 25 over 2. And that's the answer to this first part. The next part says evaluate the integral of g between 1 and 6. So in other words, that's going to give you the integral of this part right here. Now that part we know, it's already 2 by 2. That's easy. It's just a square, right? So let's write that down. That here would be 2 times 2 plus. And then the other piece will be this bit of shaded area right here. See this bit under the graph? And then kind of all of this right here. That's what we have to find. So let's work through that process. That second piece has to be an integral of the way the function is defined, which was 2 times x minus 4. That's given at the top of the question. And then you square this. You have to plug in the limits. So the lower limit is 3 and the upper limit is 6. And this is dx this way. To actually compute this, take a look, right? So 2 times 2 is 4. So it comes over here. And then you have to anti-differentiate this. So plus, there's a 2 on the outside. And then when you anti-differentiate, it's going to look like this. X minus 4, this whole thing raised to the third. And then on top of it, this whole thing divided by 3. And then you're going to plug in the limits. So the upper limit here is, let's see, 6. And the lower one is 3 this way. And to simplify this, you're going to do 4 plus and then the 2/3 on the outside for now. Maybe some brackets. And then you just have to evaluate the expression. So when that 6 goes in, you're going to have 6 minus 4 cubed. 6 minus 4 is 2. 2 cubed is 8. When 3 goes in, you're going to have 3 minus 4, which is -1. -1 cubed is -1. So it's going to be minus a -1. Be careful with the 2 negatives there. And then after that, it's going to be 4 plus, and then here 2/3, and it's going to be here times 9, essentially, this way, which is then 10, and that is the correct value. The next one says, for x between -5 and 6, on what open intervals, if any, is the graph of f both increasing and concave up? Give a reason for your answer. So to be both increasing and concave up, you need 2 conditions. Increasing condition means the following. F prime of x is greater than 0. Second condition, to be concave up, that means that concave up means f double prime of x, like this, has to be greater than 0. So look through your graph very carefully and identify those intervals, if they exist or not. So take a look. You see, here, f prime is negative. Here it's still negative, right? Here it's 0. Okay, let me focus on this so you understand what I'm saying. Like here it's 0, so it's no good. Now, take a look. This one is different, beginning here and then ending here, right here. This interval is different because f prime is positive, it's going up. On top of the second derivative, which is the slope of the first derivative, is also positive because the graph is rising. So what is that telling you? It's telling you the following, right? That one of the intervals that satisfies this is 0, 1. Then you continue here. Well, the next one doesn't really work for the following reason. Here, f prime is positive, but the second derivative is 0 because it's a horizontal line segment, you see? Now look at this one here. Again, it doesn't work because f prime is still positive, but the second derivative is negative because the graph is falling of f prime. Which means the next part that does work is this part right here. Okay, this one is okay. Because here, as you can see, beginning from 4 going over to 6, f prime is positive, and the slope of f prime, which is a measure of the second derivative, is also positive. So you can union this now together with 4, 6, and then that's the answer to this part. Now look at the last part. Find the x-coordinate of each point of inflection of the graph of f. Give a reason for your answer. So the only place where you have a switch in the values or the sign of the second derivative is right here. Take a look. At x equals positive 4. Now, why is that the case? Look at it very carefully there, okay? So to the left of the 4, f prime is positive, but the second derivative, which is the slope of f prime, is negative because f prime is falling. And then to the right of the 4, f prime is positive, and the second derivative now is also positive because f prime is rising, which means that corresponds to a concavity point on the original function. So you would conclude the following, that as in a sentence. So at x equals 4, there's a concavity point on f. And that's all the answers. Thanks so much. Please if I can subscribe. See you in another video.